Get into funkier graphs when we're exploring what are called nonlinear relationships. Now, nonlinear relationships are equations that do not have straight lines, because linear means a line, and if these don't have straight lines, then, or at least one continual straight line, then they are nonlinear. They are not straight lines. First one we're going to talk about are parabolas. Now, parabolas sort of look like arches. And as an example here, we got right here, we've got the St. Louis arch. Probably the most famous parabola that I can think of. But also you get this if you throw a ball up in the air across a distance, it will arc in a parabola. And here's another example. This is an actual parabola, how it actually looks when you graph it. And this is obviously the reverse of what the St. Louis arch does, it looks like. And all these up here are how parabolas are actually written out. Y is equal to x squared is probably the most simple parabola. And if it's a negative in front of the x squared, then you're going to end up with something that goes down instead of up, like the St. Louis arch instead of this one here. That's kind of the default. If it's negative, it flips upside down. But this is a parabola, and you can tell it's a parabola because of this term here, x squared. And so if you have anything with x squared in it, and plus a number or a coefficient, a number in front of the x squared, and a number, any of those things like that, you'll end up with a parabola. Now down here, as an example, if you plug this in, and if I plug in all the points there, you can see I have this point right here, which is negative 2. Negative 2 squared is negative 2 times negative 2, so that's going to be 4. So that's negative 2 on the x. So negative 2 times negative 2 is 4. And then I have here negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. And this is 2 times 2. And it's really important to understand you get this matching area here that if you fold it over, it will work. If you fold it over down this line, it is a line of what's called symmetry. And so it folds over, and if you have that, then it'll match up on either side the points. Now, an absolute value graph sort of looks like a big V. And again, this can be flipped over if you have a negative in front of it. An absolute value, remember, is just the amount that a number is away from 0. So if I have, and this is how it's written with the two lines here. So this is y is equal to the absolute value of x. So this is y is equal to 2 times the absolute value of x. This is y is equal to the absolute value of 3 times x plus 1. And if you look here, this here is how you graph it. It's in some ways even more simple than a parabola. Because it's just negative 2. What's the absolute value of negative 2? It's 2. So it's going to be a point right there. Absolute value of negative 1 is 1. So it's going to be right there for the value of y. Absolute value of 0 is 0. Absolute value of 1, 1. Absolute value of 2 is 2. And so these look like these. And if you're asked to identify whether something is a parabola or whether it's an absolute value graph, really the main thing you need to look at is it a V or is it this kind of arch shape? If it's an arch shape, if it doesn't have like those two straight lines that are here, like that, then it's a parabola. And if it does, then it is an absolute value graph. So now, just as an example here, when you graph it, it's the same way you would graph anything. You come up with a set of values that you plug into the equation. I'm going to do this for you quickly here. I'm not going to be able to do all of them just because this graph is a little bit smaller than I would like, but at least graphing it, but I can show you how it would work on this. So all I would do is, if it says here, make a table of values for each equation, then graph each equation. So I'm just going to plug in, and it says use the integer values of x for -3 to 3. So that's going to be -3, -2, -1, 0, 1, 2, 3. And then I'm going to graph this equation. And so all I'm going to do is set up this equation the way we did before, this chart the way we did before. And now I'm going to fill in that. And if you look here, I just went ahead and filled all this in. I just plugged in the value of -x, or -3 for x, and then that's squared. So that's going to be -3 times -3 is 9, plus 2 is 11. -2 times -2 is 4, plus 2 is 6. -1 times -1 is 1. And that's going to be plus 2 is 3, and 0 times 0 plus 2 is 2. And then the interesting thing is how it flips over and does the same thing. 1 times 1 is equal to 1, plus 2 equals 3. 2 times 2, 4, plus 2 equals 6. 3 times 3, 9, plus 2 equals 11. So if we graph all these points, all we're going to do is we're going to go start here. This one here we can't graph. This would be negative 3, 11, and it's too high up there. But here, negative 2, 6. So 1, 2 over, and 1, 2, 3, 4, 5, 6. So that's where we're going to go right there. Negative 1, 3 up, the next one. So that's what that one is right there. Negative. So 2, or 0 and 2. And then you'll see how it matches up here. 1 over 3 up. 2 over 6 up. And then if we had the area, we'd have that nice graph there. And so this is what it's going to end up looking like. I'll see if I can draw this in pretty reasonably. And it looks like that. And we can just draw that like that if you want. And it'll get narrower, and well, it'll get a little bit wider, but it won't go up by as much each time. It'll get actually, it won't spread out the way an absolute value graph always spreads out, which we'll get to in just a second. Over here, we have the same sort of problem here, and I have it set up. This here is an absolute value graph. So y is equal to 1/2 times the absolute value of x plus 1. And down here I've got that set up, so I'm going to figure that out now. So now we're back here, and I drew these nice red lines because there's a lot of right in here, so it's a little bit confusing, so I want to make sure it's clear which matches up with which. So negative 3, if I substitute negative 3 in to this equation up here, what I end up with is 1/2 times the absolute value of negative 3, which is just going to be 3. So 1/2 times 3 is 1.5. 1.5 plus 1 is 2.5. Then I substitute negative 2. 1/2 times the absolute value of negative 2, which is just going to be 2, so that's 1/2 times 2, so that's 1, plus 1 is 2. Again, negative 1, the absolute value of that is 1, times 1/2, plus 1 is 1.5. The absolute value of 0 is 0, times 1/2 is 0, plus 1 is 1, and so the absolute value of 1 is 1, so 1/2 times 1 is 1/2, plus 1, 1.5. The absolute value of 2 is 2. 1/2 times 2 is equal to 1 plus 1 equals 2. The absolute value of 3 is 3, times 1/2 is 1.5, plus 1 equals 2.5. And so now I'm just going to quickly plot these points. I'm going to do it in red. And so I just have negative 3 and 2.5. So 1, 2, 3 over, and 1, 2, so it's going to be about there. Negative 2 and 2. 1, 2 over, and 2 up. Negative 1 and 1.5, so negative 1 and 1.5, it's going to be right there. Then 0 and 1, and that's kind of our turning point when it goes back around and comes back up. So now it's just going to be 1 and 1.5, so that's right there. 2 and 2, right there. And 3 and right there. And again, you end up with this nice looking V, if you can actually draw, which is not my strong suit, but I can do better than that. So you end up with this nice looking V. It's never very good at connecting the dots. And this will just go on forever, and that's how you graph those things. So that's it, and remember that St. Louis arch is a parabola.